unit. And I think after this unit, you won't have anything in grade 9 left. Okay. Once this unit is done, then we go into our deep dive revisions or whatever we call it. Okay. Now, yeah, please.
So during the next chemistry class, can you just explain what that cells again? Simple cells?
Simple cells.
Yeah, sir. We did that in class today in chemistry. I'm sure this is video.
Okay. I'll tell you what is a voltaic cell. Again, as I'm saying, that is not there in your course, but you are learning it. That's not an issue. But that is an electrochemical cell. Cells come in later part of your chapter, but I'll explain you. Don't worry. On your next class, just remind me. Okay. Right. Fine. So we today our discussion of topic will be waves. In fact, after you have come out from mechanics, then you went into heat, and now you are coming into waves. Now this is for some people this is very easy as they go in higher classes. For some people this is not complex, very complex. You are going to start your first discussion about waves. I may not follow the book initially because the book attacks it from one perspective only, but this is a complete horizontal in physics. So let me give you a couple of 2-3 minutes to make you explain what is wave. Wave exactly is not a chapter. Wave is actually a tool or a mechanism. And if you don't understand it properly, it is nothing of what I call a classical physics. Like, it cannot be grouped under mechanics, it cannot be grouped under heat, it cannot be grouped under sound, light. This is a tool. This is like a horizontal. Horizontal means it will be spinning across at least 2-3 topics. Okay. If you don't understand waves properly, especially the mechanics of waves, then in later on, if you study science, you will have problem in sound. So I'm not trying to make you afraid. You will have issues in light. You will have issue in electricity. Okay. Because all these chapters are classical physics, and in these chapters, waves form a very, very important part. Even when we later on go and study something which is known as SHM or simple harmonic motion, okay, in all these three, 1, 2, 3, 4, in all these chapters, wave is going to be a part. So wave alag se koi chapter nahi hai. It is like learning trigonometry, or it is like learning algebra. जो भी आप chapter पढ़ोगे उसमें ये चीज आएगा. In these, this chapter will come. I tell many people, like, wave is something like, at your age, to explain what it's like studying about love. अलग अलग relation का अलग अलग love है. Father and son अलग, mother daughter अलग. Then you say, boy and girl falling in love, that is different, but the component of love remains the same, and you're going to study it across many things. Okay. So before we go into waves, and the first section of your chapter, though done very quickly, that is actually the most important part. Let us understand something which is known as periodic motion. Any idea for anyone what is a periodic motion? If you don't discuss, then it becomes monologue. I only keep talking. Do you have any idea like what is periodic motion? A motion that repeats itself after a specific interval is called a periodic motion. You show your face to me. Every Tuesday you show your face. That is periodic. And what is the periodicity of showing face? 8 days. Whenever you have done, why not? When you said that you are converting, irrational, how to convert a irrational number to a rational, or not irrational to a rational, to decimal to a rational number, you used to sign the periodicity. Periodicity means the repetition. Any motion which completes. Earth goes around the sun in how many days? 365, 1/4 days. That is a periodic motion. इतने period के बाद वो motion फिर से अपने आप को repeat करेगा. Right? So any periodic motion. So what are the best examples of periodic motion? यहाँ से भी बहुत कुछ interesting आएगा. So if you see rotational motion, like the fan is rotating, okay, that is also a periodic motion. After a particular period, the fan is coming at this place, rotational motion. Then comes ये एक हो गया. इसके अलावा आप क्या मोशन देख सकते हैं? Planetary motions. Planetary motions are also a sort of periodic motion. Then comes a very unique type of motion which is known as a oscillatory motion. Do you know what is an oscillatory motion? Oscillatory motion भी एक होता है and something also known as a vibratory motion. Any idea what is an oscillatory motion? Anyone? What is oscillatory motion?
Is it like when there's like a small one, it goes
Like a simple pendulum to and fro motion, right? So somebody is saying that there is something called a to and fro motion. To and fro motion, that is also known as an oscillatory motion, vibratory motion. How about a swing? A child is being put on a swing, and then the attendant, the mother or the relative who is with the child, she or he is just swinging the child on the swing. So खाना खिलाते हैं ना बच्चे को, देखो बहुत सारे बच्चे घर में खाना नहीं खाते हैं, तो how do they feed them? They put it on the swing and keep the teaspoon ready. So the child goes that side, 2 सेकंड बाद आता है, टपक खा लेता है. By that time again one spoon taken goes. So after some time you will see whoever is the attendant has adjusted the timing in such a way that उसी टाइम में चम्मच लेने से बच्चा आता है, टप करके खा के फिर चला जाता है. Periodic motion. In fact, you may not look at the child also after some time. Once you are able to synchronize yourself with the period of the child's reaching you, you just need to put the hand like this. वो बच्चा खा के चला जाएगा, आप हाथ ऐसे कीजिए. And all sorts of robotic motions which we see in things like filling up of an ice cream or filling up of jam. If you see those machines which are in assembly line, all these machines are working with a periodic motion. एक चीज ऐसा घूमता है, एक ऐसे आता है, टक करके डालता है, फिर आगे जाता है. Again it comes, टक करके डालता है. Right. So these all are known as periodic motion. These periodic motions को अगर आप, if you want to represent these motions schematically, okay, schematically, then one of the way is wave mechanics. With wave mechanics, we can understand these motions much more in detail. Wave एक ऐसा mechanism है with which we can, explain any sort of a periodic motion. And precisely the type of motion that we will be explaining later on, like sound can be expressed in waves, light can be expressed in waves, electricity can be expressed in waves, simple harmonic motion also can be expressed in waves. We're going to study these later, what is what, but just now try to understand. If you have a periodic motion, a motion that repeats itself, periodic motion means any motion that repeats itself, okay, after a specific interval. Such sort of a motion will be known as a periodic motion. And if you look into the class of these motion, rotational motion is something which is rotating. Oscillatory motion is something interesting for us. What is an oscillatory motion? A simple pendulum, something which is held straight, which is known as its mean position, and after that it starts oscillating. It repeats itself after a period, every period. Like if you see the grandfather clock and all those things, then those clocks are repeating itself after every 1 second. Tung. This is 1 second. That's how the clock has been set. That every time the pendulum comes back to its particular position, it's 1 second. So it's a repeated period. Okay. So oscillatory and vibratory. Khali oscillatory motion mein we need to, vibratory motion is what? Take a guitar string and you just pluck it. The guitar string vibrates. Originally the string was here, then the string becomes a bow on the top side and a bow on the bottom side. Tang, 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 is vibrating, and vibrations create sound. इसलिए sound को पढ़ने के लिए भी wave चाहिए. ठीक है? And oscillatory motion is when, and what is the difference between oscillatory and simple harmonic? Okay, simple harmonic. Have you seen somebody sawing wood? Wood को saw करता है ना? ये भी repetitive motion है. This is called a quick return mechanism. This is also periodic motion. We call that a simple. When do we call it a simple harmonic motion? We call it a simple harmonic motion when the displacements are so small that they are like straight line. Agar aap, if you take a pendulum and you oscillate it like this, like a swing, it is called oscillatory motion, but not simple harmonic. Simple harmonic hone ke liye, the motion should be absolutely oscillating so that curve is not formed. आप समझ रहे हैं? ये सब higher classes में आपको use आएगा. For example, this is a pendulum. If you are actually swinging the pendulum like this is like how you are swinging the child. You are actually forming curves. Curves ho jane se, is this vibratory motion? Yes. Is this to and fro motion? Yes. Is this oscillatory motion? Yes. Is this repetitive motion? Yes. Is this periodic motion? Yes. Is this simple harmonic motion? Simple harmonic motion के लिए the deflections have to be very less so that this is almost like a straight line. Very small, tick, 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 like that it has to do. So if somebody says that there is a hacksaw which is continuously, mechanized hacksaw, like a plotter, is it simple harmonic? Yes. Why? Because its displacements are all in straight line. Is it periodic? Yes. Is it repetitive? Yes. Is it to and fro? Yes. Is the displacement a straight line? Yes. So it is simple harmonic motion. The displacement is not straight line. ये oscillatory होगा. So all simple harmonic motions are oscillatory, but all oscillatory motion need not be simple harmonic. ये चीज समझ में आया basic. तो ऐसे मोशन को ग्राफिकली रिप्रेजेंट करके इफ यू वांट टू एनालाइज द मोशन इन डेप्थ देन वेव इज वन टूल. Wave is not a topic of classical physics as a chapter. Wave will show its face when you study sound, when you study light, when you study electricity, when you study simple harmonic motion. That means wave is of very utmost importance, and as well as when you study advanced mathematics in terms of algebra and other thing, ऐसा कोई चीज नहीं है जहां वेव नहीं है. सोफा में जाके बैठ जाते हो, टिंची 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 करते रहता है सोफा, उसमें भी वेव है, बिकॉज इट्स अ रेपिटेटिव मोशन. ठीक है, आगे बढ़ते हैं अभी. Now let us analyze some things. Let's say you are at a place in Australia. आप Queensland के किसी beach में हो. This is a beach, okay? And in this beach, you are enjoying what is known as waves. ऐसे waves हैं. And the waves हैं, right? And what do you observe when you are enjoying at a beach? You observe that these waves are traveling towards you, है ना? waves आपकी तरफ travel कर करके आ रहा है. ये आपका पहला myth यहाँ पे clear होगा, right? Are you understanding? Trying to visualize yourself what is happening. So let's say this is you. You are here at the beach and you are enjoying the wave which is happening. Now tell me the first question. In waves, does the water come to you? All of you must have gone to a sea beach. Now you don't be quiet here. Quietness kills me. In a beach, does the water come to you? You all go and stand and you allow the water, you see water coming, you click selfies. Does the water come to you?
Yes.
Yes, that's the first myth which is wrong. The water doesn't come to you. Water doesn't come to you. The disturbance comes to you. How to prove it? So how to prove it? There's a lovely little example. ये एक टिपिकल बर्ड है. इस बर्ड का एक नाम होता है, गिलेमॉट बोलते हैं इसको. It is a bird which is found in North Atlantic as well as in Pacific Oceans, right? And in Australia this is very common. This is a guillemot. A guillemot क्या करता है? पानी में रहता है, and the wave is coming. If the wave would have been coming to you, then what do you expect? The guillemot should come to you. वो आ जाना चाहिए. इसका weight इतना थोड़ी है, इसका weight नहीं है. But you actually will see what you know. You will actually see this fellow going up and going down. Now the illusion that you get is the water seems coming to you, the bird never comes to you, and the bird is keeping on going up and going down. This gives us the first impression, we'll have many examples. The first impression that in wave, I would say, which you will not agree with me. First of all, you will not agree with me, which is very common. The disturbance travels, the disturbance, TRAVELS, travels, but the particles remain where they are. Right. Rather, I would say, and you will not agree with me. I'm upfront telling you. Right now, you'll not agree. Rather, I'll say the particles oscillate at their respective positions. So, which is very, very contradictory to you. You'll not agree that as you're standing on the sea beach, you find your sir is now telling you that the water does not come to you, the disturbance comes to you, the particles oscillate where they are. In a better way to understand, if there was a guillemot like a bird out here, the bird will never come to you. Bird अपनी ही जगह में up and down हो रहा है. Why is it going up and down? Because the water here is going up and down. So another way to understand what I'm saying is, let's say we freeze one molecule out here. This is our cute little molecule of water called M. This molecule will never come to you. This molecule keeps on vibrating at its place, oscillates at its place, but there is a disturbance and the disturbance is traveling to you. Wave is that disturbance. You might agree only 10% with me right now. Is this example understood? Understood. You may not agree with me, but you will agree after 2-3. You may not agree. Is समझ में आ गया? I'm standing on a sea beach and I see waves coming towards me. I see waves coming towards me. A wave is a periodic disturbance which travels towards me, and the particles don't travel towards me. Particles oscillate at their respective position. What I'm seeing is only an illusion of a disturbance coming to me. Guillemot stays where it was. Or if I freeze a molecule of water, M doesn't travel to me, M remains. Pretty hard to believe, but this is truth. Let's go to example number 2. Right? So in example number 2, we get inside something which is known as a big cricket stadium or a football stadium, as we can. It's big football stadium, jam-packed. Okay, it's a jam-packed football stadium. So out here we have got all our spectators. These are our spectators, and similarly we'll have spectators out here. We'll have spectators out here. We'll have spectators out here. What we do is that we freeze 2 spectators out here. This is one and this is one. These 2 are our spectators of interest out here. And we are watching a soccer game. I hope by now you understand what is a Mexican wave in a soccer. The word came from, begun in Mexico 86. When World Cup was played in Mexico, this is the first time it came up. It was called a Mexican wave, where people just lift their hands up. Right? People will lift their hands up, and as the roar starts building up, whether it is cricket or not, now consider yourself to be this spectator. What do you see on the other side? A wave has started to generate. समझ रहे हो मैं क्या बोलने की कोशिश कर रहा हूं? This particular person who is actually sitting on this side, every time what happens? This person will raise his hands, then his hands will come down, his hands will go up, his hands will go down, his hands will come up. So this person starts watching that a wave has started to build up, and the commentator says, yes, the Mexican wave build up. It's a huge roar going on in the stadium. Right? And let's say this lady is Stella, beautiful looking, and this fellow is Mark. Cambridge है ना, तो देसी नाम डालने से नहीं होगा. Mark is liking Stella. Mark, if you are correct on that, the previous slide of mine, and you think that the water comes to you, then Stella should come to Mark. Does Stella come to Mark? No. But something is coming to Mark. He gets ready. The disturbance is traveling. And it's a periodic disturbance. Hey. Particles of matter are oscillating at their respective places only. Hands up, hands down. Hands up, hands down. But this person observes what? A wave has been generated. Kirtan, what are you doing, dear? What notes are you taking? I'm speaking about a cricket stadium. That I have written in the first slide itself. Yeah. Here to understand more. Okay, very good. So if you see at this side, what does this person see? A wave has been generated out here. So maybe now by 40% you will agree with me that if I again start writing out here that wave is a periodic disturbance. Wave is a periodic disturbance, okay, in which the disturbance travels. The disturbance travels, or ek minute beta, or I say the disturbance propagates and particles oscillate at their respective position. So what I want to stress again is that particles do not move. In my previous example, the molecule M does not come to you. The guillemot bird doesn't come to you. Here, Stella doesn't come to you. But the disturbance comes to you. Yes, your question.
Whenever some, like in the ocean example, like something comes towards
The disturbance, I'll tell you that. First, you start agreeing with me. Otherwise, we will not be able to converge because in our mind, it's still that the water comes to me. वाटर नहीं आता है हमारे पास, डिस्टर्बेंस आ रहा है हमारे पास. आपके पैर के पास जो पानी पहले था, that same water is there. That water sometimes goes up, sometimes goes down because of a disturbance that is coming. Say suppose let us name those water particles beside your leg. Chunnu, Munnu, Sonu and Mohan. They are the water particles beside you. Chunnu, Munnu, Mohan continue to remain at your feet. Sometimes they are splashing on your face, sometimes they are at your feet. But you believe some Gayatri, Mohan, Rana from there are coming on your legs. Na, 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 na. Disturbance comes. ये तो proof हुआ ना इसमें. Is the wave not traveling towards your ground, your stand? Yes, it travels towards your stand. Did any person travel to you? No. But did you visually see that something traveled to you? Yes, I saw. What was that? Disturbance. Who created them? All the people. Is anyone out of his seat? No. Is anyone oscillating at his seat? Yes. Did anybody? Nobody's running across in the stadium. Do you agree or not? Wave has been created. Maybe now you agree 45% to me. एक और example देते हैं, and this will nail you. Right. So we go to a gym now. Right now we are at a gym, and our gym trainer has given us an exercise. So this is say our Srinika madam. Okay, this is our Srinika madam, and she has been given an exercise that एक rope दे दिया है, and there's a rope lying on it, and the gym trainer has asked her, hold the rope, and you start doing this to build up your biceps. Okay, good. And let's say we keep Nidhi standing out here, and we ask her, you keep observing. So let's make the rope for Srinika. So here is the rope. Is this color visible? I don't know. Okay. Okay. So Srinika is now shaking this rope. Okay. So what she is doing is she is shaking the rope up and down with her hands. And me, because I have to make you agree. So what I did, I took a small, that red satin ribbon hota hai na, packing wala ribbon. I took a ribbon and I tied a small knot out here with a red ribbon. Initially, I did not tie any ribbon. I did not tie any ribbon at all. And I told Srinika, now start shaking the ropes. So as she starts doing this, I asked Nidhi, what are you seeing? Nidhi says, sir, I see ropes. Nidhi starts saying that, sir, I see waves which are traveling in this direction. Oh, wow, good. That means the rope is traveling. ऐसा तो हो नहीं सकता है. The rope is fastened here and the rope is fastened at her hands. But she is observing that something is going. Can you imagine if you do this thing in the... So she is observing that the disturbance is going. To now make her correct what I say or to prove my point, I actually tie a satin ribbon out here, small. Now what does this girl see? You know, this girl actually will now get the truth of her life. She will see that sometime the rope is going down and sometime the rope is going up. And this particular satin ribbon is just oscillating at its own place. However, there is an illusion that a wave is traveling towards Srinika. ऐसा कैसे हो सकता है? रस्सी थोड़ी लंबा हो जा रहा है. जो रस्सी था वही था. Do you now understand? Wave is a periodic disturbance, and if I ask Srinika, Srinika, slow down, the wave gets killed because you have disturbed the period. A new form of wave gets created. आप जोर जोर से shake करोगे तो big waves you'll see. If you start slowing down, then you see a different pattern. But you have to maintain a period. You can't do. ऐसे नहीं होगा. Periodic means we have to gauge. Yes, अभी श्रेणिका up है, अभी down है, अभी up है, अभी down है, अभी up है, down है. टक 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 टक. Periodic. ले ध्रुव अभी prove हुआ कि नहीं? Wave में एक चीज दिमाग से निकाल दो, that the particle of matter travels towards you. A wave is a periodic disturbance in which the disturbance propagates. particles of matter remain at their respective position and they just keep oscillating. How they keep oscillating, that we will discuss. So first thing, let us get into our mind. A wave is a periodic disturbance. It happens due to, it is the outcome of a periodic motion. Sir, what type of periodic motion it can be? Anything. Rotational, repetitive, quick return, oscillatory, vibratory. So vibratory motion को wave में दिखाना बहुत easy है. रस्सी बांध दो, you can see. Even rotational motion also you can see in wave. We will see that. How can you see rotational motions in wave? Something is rotating. Sir, rotation में wave कैसे दिखता है? इसमें तो समझ में आ गया. Even Mexican wave is up and down, vibratory. How do you see rotational motion में wave? We'll see that also. Is this clear? Right. And a wave will always transfer what you know. A wave will always transfer something which is known as energy. होना ही पड़ेगा. The water which was here kissing my feet suddenly goes and splashes on my face. Who gave it energy? The wave gives this energy. So wave transmits what? Wave transmits energy, not matter. Matters remain at their respective position. Up to this level of discussion, if anyone has any query, or you can see physics is not about what I say is correct. You have every right to dispute. Maybe you will at last get wrong, but there is a pleasure in learning that way. You can dispute with me. आप dispute करो, dispute करो. जब तक आपका मन नहीं बोलता है कि yes, now I agree what he said. Now if I go back, see, if I go back to my previous discussion, I first said that in this expression, example, you might have not agreed with me that wave is a motion in which the disturbance only travels. You will feel, no sir, water travels to us. What do you say? It took away my hat. No, that same water was there at your feet. Then the next example makes you a little bit more understand that yes, particles do not move. It's only a disturbance. And the third one actually nails you with this satin ribbon being tied, that the ribbon just goes up and down. Clear hua hai? Right? So this is wave. Wave is a graphical way, or wave is a mechanism of representing any periodic motion. Now with respect to wave, we will learn certain terms. Before we get into wave, we have to learn certain terms. Is this level clear? यहाँ तक कोई doubt है बच्चा? इसके बाद you read your book, everything will fall clear. Maybe I'm teaching you a little bit more than the book, because only that way you'll, I believe you will understand. Now let's get to know some important terminology. Now, this terminology will be associated with waves, whether you are studying it in sound, light, electromagnetism, electricity, optics, simple harmonic motion. However, to explain these terms, the easiest way is to explain it with a simple pendulum. I will draw a pendulum, which is again not there in your book. उससे आप समझ जाओगे जल्दी. But these terms are something that you will understand, which are same whether you are studying this chapter or any other chapter. So let's first understand what is a simple pendulum. So a simple pendulum is a non-stretchable, observe my words, it's a non-stretchable string. Non-stretchable matlab, the string cannot be an elastic. It's a non-stretchable. Okay? And at the end of the string, I have something which is known as a ball sort of a thing, and this thing is known as the bob. Okay, तो इसका नाम दे देते हैं. क्या बोलेंगे? This is known as the bob, and there is a string, and the length of the string is finite. Which means the string is not elastic. It does not increase due to the bob being hung on it, right? This is a simple pendulum. And it should be free to oscillate at its point of suspension. This is the point of suspension. The pendulum should be free to oscillate. समझ में आया? Right. The position when it is right vertically out here, this position is known as mean position. This is known as mean position, also known as the central position. This is also known as the central position or the mean position. Right. Now with this, I can create vibratory motion, I can create oscillatory motion, I can create simple harmonic motion. Vibratory motion, तो vibrate करा दो. Oscillatory motion, ऐसे लगे छोड़ दो, ट्वी कर रहा है oscillatory. But simple harmonic motion, I will just give a disturbance which is very small, so that it just makes straight lines. Okay. So we'll not go to simple harmonic motion now. So we will concentrate on having what is called, let's say, oh, sorry. So fine. Clear, Vacha? Right. Now, the new positions that you have created, these are known as extreme position. So this will be known as my extreme left, and this will be known as my extreme right. Right? Extreme left and extreme right. Clear? Now what I do, my pendulum was like this. So I initially take the pendulum to this side, make sure that the string should not become slack, it should be straight. I take it this side and I now hold it at this position, and I call this as my position 1. Position 1, where I'm at the extreme left. I don't push it, I just release it. Because of its weight, the earth will pull the pendulum towards itself. Because of that, the pendulum will immediately go towards the other side. So the pendulum moves from 1. From 1, the pendulum moves towards 2, right? This is known as 1-2 motion. 1-2. 1-2 means, don't take it as 1-2 means 2 numerical. 1-2. This motion is known as 2. इस तरफ जा रहा है, इस तरफ जा रहा है. And how many twos? 1-2. Rather in Hindi it is easy. 1-2. 1-2 motion हुआ. 2 means when something goes away from you, it is known as 2. And when the thing comes back towards you, it is known as fro. ठीक है ना? So after this, what happens? After this particular item, then after it goes here, then due to its inertia and all, it will again come towards me. So from 2, it has now come to position number 3. This is called 1 fro. Ek fro motion. 1 fro. 1-2 and 1 fro. Okay? Now, let's get our definitions correct now. So, one cycle comprises of 1-2 plus 1 fro. This is known as one cycle. One cycle is also known as one vibration. Ek vibration. How many vibrations? One vibration. One vibration consists of 1-2 and 1 fro. Have you understood? So this is called cycle. So by now you have understood what you mean by cycle. This cycle is nothing but the period. Why is it called periodic motion? ये periodic क्यों है? क्योंकि एक निर्धारित समय में जाके फिर उसी समय में वापस आता है. Look at the earth. 365 days में जाके again it comes back. And you people celebrate by partying and doing whatnot. Aliens observing you say, look at those morons. Their earth just completed one periodic motion and they are spending money. Because for you it is Happy New Year. But any other alien sees, oh, yeah, what idiots here, one motion complete kiya hai, for that they're doing. समझ में आया? So one cycle is same as one period. बोल लो आप इसको. You show your face to me every 7 days. So what is the periodicity of our meeting? 7 days. So for us, this is 7 days is equal to one period. Are you getting it? 24 hours is equal to one period for the day and night to happen, rotation to happen. And in a pendulum clock, grandfather's clock, 1 second is said to be the period. 1 second. 1 second. 60 times jana, 60 times ana comprises of 1 minute. Have you understood now? Okay, so cycle hum samajh gaye. Next, once you have understood cycle, the next thing you have understood cycle, so you should understand something called time period. Now these will be very common, whether you study electricity वगैरह सब में ये चीज आएगा. Time period. Time period is very easy. Time period is stated as T measured in seconds. It is the time taken time taken to complete one cycle. अच्छा, one cycle का एक और नाम भी होता है one oscillation. One cycle is same as one oscillation. Time taken to complete one cycle. That means यहां से यहां जाना and again वापस आ जाना, the amount of time it took. So this is a very common experiment that we used to get in our school days. This experiment is never given to one person, it is always given to two persons, because it is not possible for you to release the pendulum, see the clock, and again find out at what time it came back. It's very fast. So what do? We have two persons. Say suppose me and Dhruv are doing this experiment. Dhruv will have the stopwatch in his hand and I'll hold the pendulum. Okay, this is ATP. Dhruv says, sir, start, and I release it. And he starts the clock. We will not count for one oscillation. One oscillation का time लेना बहुत मुश्किल है. So we'll count for 10 oscillations. गया, आया, 1, 2, 3, 4, 7, 8, 9. Now my partner becomes alert. 10, and he stops it. What did he record? He recorded the time taken for 10 oscillations. Can he now find out what is the time taken for one oscillation? Very nice, divided by 10. But he must have done some errors. So this experiment we will repeat for 3 times. For 10 we will take set of 3. For 15 we will take set of 3. For 30 we will take set of 3. Ultimately, we will get the same time in and around for one oscillation. कभी 3.2 second मिलेगा, कभी 3.1 मिलेगा, कभी 3.4 मिलेगा, and then we'll take an average of that. That is the best way to do the experiment. Have you understood the experiment or not? 10 oscillations के लिए 3 बार किया, 15 oscillations के लिए 3 बार किया, and then 20 oscillations के लिए 3 बार किया. So that for the 10s we will have an average, for the 15s we will have an average, and for the 20s we'll have. All these numbers will be almost near about to each other, unless and until this fellow or I have goofed it up. Got it? And many other, okay. So that will give us what is known as the time period. So we say time taken to complete 1 second. Okay. So sorry, 1 second, one cycle. So time period is measured in seconds. Any doubt till time period? No. Yeah, bolo betu.
But so, like if it's one 10 times, won't it like become smaller than the oscillation? Like it goes like this and then won't it start?
Yeah, but see, a very nice question. Actually, when we do it, that's the reason that if you take it, see, if you have to do this experiment in an environment where there will be some friction out here. Ultimately, this pendulum is going to stop. It's going to come and stop, right?
Yes.
Right. That happens. Then also air resistance is there. But if you would have done this experiment in space or a place where friction, suppose there is no friction, you cannot rule out friction. But say suppose you have ruled out friction, आपने rule out कर दिया, no air resistance, ये pendulum पूरी जिंदगी के लिए नहीं रुकेगा. Such machines are known as perpetual motion machine, PPMs. If you go to any science museum, they will always show you certain motions which are perpetual motion. Means there will be some spirals which are keeping on moving. Actually, they move it by motors, but perpetual motion is also a concept. It is possible, but for that we should rule out any sort of what you call friction, any sort of air resistance. That's why we don't take it for many counts. But if you take a small pendulum and you do it up to 30 oscillations, it will not come to a stop. It time lega. Have you seen that James yo-yo? Yo-yo था ना आपका? आप yo-yo को लेके ऐसे हिलाते रहो ना, कम से कम 150, 160 cycles it will make before it comes to stop. It won't come to stop so quickly at all. ठीक है? So we have understood what is a cycle, we have understood what is oscillation, we have understood what is time period. Our next in queue is a guy whose name is frequency. Frequency. Now there's a little bit of challenge in understanding time period and frequency. Frequency is number of oscillations or cycles per second. Very interesting here. Please understand. Say suppose Dhruv and me were doing an experiment and we found that 30 oscillations took 30 seconds. So one oscillation took how much time? 1 second. What is the time period? 1 second. Now the question is, what is the frequency? Frequency means 1 second में कितना cycles? 1 cycle. But let us change the data now. Dhruv and me did an experiment in which 30 oscillations took 15 seconds. So one oscillation took 30 oscillations took 15 seconds. So one oscillation took half second. So what is the time period? Half second. Now my question, what did you understand? That means to complete one cycle, it took half second. फ्रीक्वेंसी वो नहीं है. फ्रीक्वेंसी आपको पूछता है एक सेकंड में कितना ऑसिलेशन. नाउ द आंसर विल बी 2. हाफ सेकंड में 1 ऑसिलेशन. सो 1 सेकंड में कितना हुआ होगा? 2 ऑसिलेशंस. लेट अस अगेन चेंज द डेटा. Dhruv and me are doing an experiment in which in 30 seconds we got 60 oscillations. 60 oscillations, sorry, opposite. 30 oscillations took 60 seconds. 30 oscillations took 60 seconds. That means each oscillation is taking 2 seconds. What is the time period? 2 seconds. What is the frequency? 2 सेकंड में एक साइकिल कंप्लीट करता है. 1 सेकंड में हाफ साइकिल कंप्लीट करता है. So are you understanding this thing? Frequency is number of oscillations. Frequency. How many times does a data repeat itself? In mathematics, that is frequency. What is your frequency of showing your face to me? Twice in a week. एक वीक में 3 बार मुंह दिखाते हो. टाइम पीरियड क्या है? 7 days. Are you understanding? So frequency we say is number of oscillations and its unit is CPS. CPS stands for cycles per second. Cycles per second. Also frequency's unit can be second inverse, that is per second. Second inverse means per second. And in the honor of the German scientist, इसका एक और unit है जिसको हम बोलते हैं hertz, and it is written as Hz. This is more commonly used. So now question comes. The frequency of a pendulum is 2 hertz. What does that mean? In 1 second, the pendulum makes 2 cycles. The time period of a pendulum is 5 seconds. That means the pendulum to complete 1 cycle takes 5 seconds. So based on all these discussions, we will see that frequency is 1 upon time period. Very important expression. सोच के देखो. If your time period is 2 seconds, what does this mean? To complete one oscillation, you took 2 seconds. So my question to you is, your time period is 2 seconds. That means to complete one cycle, you took 2 seconds. Now my question to you is, what is the frequency? Then you will ask yourself, sir is asking, in 1 second, how many do I make? Half. 2 seconds means 1 cycle takes 2 seconds. So frequency means 1 second में half cycle. So look at frequency and time period. They're just reciprocal. Sorry, frequency and time period are just reciprocal of each other. If frequency, that's why time period. What is the unit of time period? Second. What is the unit of frequency? Second inverse. Because they are the reciprocal of each other. ये चीज समझ में आया? बहुत इंपॉर्टेंट है. ये क्वेश्चंस आपको आएंगे. So and so. So can you just correlate one small example, like say 500 oscillations. 500 oscillations take 10 seconds. Get me the time period and get me the frequency. 500 oscillations take 10 seconds. Time period is 1 upon 5. And frequency should be 5. 10 सेकंड में 50. 1 upon 50 and 50. 10 सेकंड में 500 times. 1 सेकंड में 50 times. So the frequency will be 50 hertz. The time period will be 1 by 50 seconds. So very interesting thing. If the time period is less, the frequency is more. If the time period is less, the frequency is more. उसका एक समझ ले. एक और. Let's take one more. See what I said. भाई don't get confused. Frequency is 1 upon time period, or time period is 1 upon frequency. What did I say? I said if the time period is less, the frequency should be more. You want to understand it? ऐसा एक एग्जांपल दूंगा. Where is Dhruv? है, देखो 1 मिनट में क्लियर हो जाएगा. Again, my examples are very teen-oriented example. Imagine this is the crush of Dhruv, and imagine this is Dhruv, है ना? कैसा मजा आ जाएगा ये एग्जांपल देख के. This is Dhruv, and he is cycling. To have one glimpse of her, just understand. If his time period means time taken to see her, if you reduce that time, that means he's cycling fast. So the number of times he will appear in front of the girl automatically increases. Frequency of seeing the girl increases if the time period is less. If you have more time period, आराम से चलाते हो, इसको देखो भी कम. अगली बार आओगे तो उसकी मम्मी सामने खड़ी रहेगी. सत्यानाश तुम्हारा. केस समझ में आया अभी? If the time period is less, the frequency is more. Right? Have you all played this game in childhood? I mean, nowadays, I don't know. If you get a big wall like this, a wall, think of a wall like this, and in this wall, you can trespass on this side and trespass on this side. It's like a wall in front of you. So when we were kiddos means absolutely in grade 1 or 2. So we'll stand on one side of the wall and our friend will stand on the other side, and then we'll peep from this side. The other fellow is to peep this side. Dikhna nahi chahiye. So if you increase the time, the number of times you'll see each other is automatically less. Right? Another game which we have played in childhood, catch the fish. We keep on moving our finger like this. So it's basically the same finger. Agar iska frequency बढ़ा दूंगा, so the chance of catching it, imagine this particular fan. The fan has got 3 blades. If the fan rotates very slowly, more time period, the chances of you getting hit is very less. The frequency of the blade coming to you reduces. But if the time period increases, just समझ में आ गया? Yeah. Okay. So a quick revision of whatever we have learned so far, so that we don't mess up the things. Okay. So what did we learn so far? Check yourself whether you are clear with this. Do you have a fair bit of understanding of what is wave? A wave is a periodic disturbance that transmits energy from one place to another place. In a wave, it is only the disturbance that propagates. The particles constituting the wave, which may be a water wave, which may be a sound wave, which may be an electrical wave, which may be whatnot, light wave, particles do not change their position, barring that they oscillate at their respective places. It is a disturbance that keeps on propagating, right? In order to understand certain terminologies of wave, we took the example of a simple pendulum, and we understood a concept which is known as time period. Understood? Then we understood something called frequency, represented by either hertz or second inverse, and time period is always. And then we got into an equation where we said time period is 1 upon f, or you can say f is equal to 1 upon t. बोलो बच्चा, यहाँ तक किसी को कोई दर्द है? समझ में आया? क्लियर है? राइट. अब एक और चीज हम समझेंगे, उसके लिए फिर से पुराने स्लाइड में चलते हैं. दिस ओके. नाउ कॉन्सेंट्रेट ऑन दिस पार्ट. This is my central position, and this is my extreme right, and this is my extreme left. The maximum displacement from the central position to either of the extremes is known as the amplitude. What did I say? The maximum displacement from the central position to either extremes, it may be either extreme right or extreme left, is known as amplitude. When we actually understand it in wave mechanics, we are going right, we call it as a positive amplitude. इसको हम negative amplitude बोलेंगे, प्लस से माइनस से. समझ में आया? ठीक है. तो what our friend Ashmita was saying, अगर झूला झूलाएंगे, बड़ा बड़ा एम्पलीट्यूड दोगे, that means the झूला will go this way, लंबा लंबा. छोटा एम्पलीट्यूड means tweet. ठीक है. तो आइए उस डेफिनेशन को भी आगे लिख लेते हैं. So our next thing that we learned, the fourth thing that we have learned is amplitude. It is measured in meters. It can also be measured in angular amplitude. Theta may be measured kar sakte hain, how much theta you are moving, but we'll measure it in meter. Amplitude means maximum displacement of oscillating body from central position to either extreme. This is known as amplitude. You must have heard this radio terms, AM, AM. AM means amplitude modulation. FM, FM, radio city FM. FM means frequency modulation. ओके AM. अब देखो एम्पलीट्यूड की ब्यूटी देखो, एम्पलीट्यूड क्या बताता है हमें, इंटरेस्टिंग, आपको क्लियर समझ में आ जाएगा. सो लेट्स से ये स्पीकर है. How does amplitude play its role? This is speaker. Have you seen loudspeakers? This is a speaker. This is a magnet of the speaker. This portion is known as what? This is known as the membrane. This is known as the membrane. So as you go on playing your songs, आपका membrane का position क्या होता रहता है? आपका membrane इस साइड भी जाएगा, इस साइड भी जाएगा. दिख 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 दिख. ठीक है? तो आप जो गाना समझ है ना, हुस्न तेरा जलवा ऐसे. So the amplitude actually controls how much is the loudness. Amplitude is a direct reflection of loudness. To create a loud sound, the amplitude has to be high. So a loud sound, now there are very interesting things. A loud sound need not be heard from a distance. If I'm playing the song loud in my house, the sound is loud in my house, it does not mean that this song will be heard by somebody who is at Girdhari. A high frequency sound will be heard at Girdhari. To give you another example, these are very things which are myths actually. आप जोर से म्यूजिक सिस्टम बजाइए आपके घर पे, it won't be heard up beyond 3 towers. But if a child cries at your house at night like that, that will be heard far away because the child's frequency is very high. Have you seen girls screaming? That is called a shrill. The shrill can be heard from a long distance. A man cannot scream like that. That's why you are into music. When we sing for boys, chota bachcha, if you are singing for generally say kids, you're playing playback, then for kids the playback will always be given by a girl or a lady, because the man cannot go to that pitch. बच्चे generally low scale में नहीं गाते, ऊपर गाते हैं, है ना? So how is the shrillness like? A baby boy followed by a baby girl has the maximum shrillness, then baby boy, then comes baby, whose voice should have the lowest frequency? A man, followed by a lady, followed by a baby boy, followed by a baby girl. A baby girl's frequency will be the highest. That's why when we try to match the singing scale of a baby girl, we will always go on a higher scale. वो low scale में गा ही नहीं सकती है. Whereas a man cannot sing at that scale. Man हमेशा नीचे गाता. And very few singers are gifted to sing at high scale. They say Kumar Sanu can sing at a high scale. His throw is more. But if you see many other singers, they do not, but they are singing the same melody. Please don't confuse between them. So the amplitude will always control the loudness. और जब आप खूब volume बढ़ा देते हो, when you are giving volume, you are actually controlling the amplitude. उसने तेरा जलवा ऐसे करके ज़्यादा volume दे देके भट करके फट जाए. Have you understood? So when you're studying sound and you study waves and you come across the word amplitude in sound, always remember, whether in this class or later class or higher classes, whenever you hear about amplitude, you are referring to the terminology of loudness. But I said waves can also be in light. Can you now by your common sense think that light ke chapter mein if amplitude comes, what is the parameter it will refer to? Brightness. The perfect word is intensity. So later on, we'll study in higher classes, do you get a dark spot or do you get a bright spot? If you want to get a bright spot, your amplitude has to be maximum. Bridge. Every bridge keeps on vibrating when cars go on top of them. So if the bridge vibration amplitude increases maximum, then what happens? The bridge collapse. वही है, rubber band ले लो, everything. That's why we say, hey, आता माजी सटकली, मेरे दिमाग का ना ज़्यादा amplitude मत दो. You are actually playing with my tolerance level. The day my tolerance level increases to maximum amplitude, I lose my temper. That's what it happens. So is amplitude clear now? So we have understood about amplitude, we have understood about time period, we have understood about frequency, and we have also, so in terms of sound, just to give you an example, a more shrill sound has more frequency. A more frequent sound with more frequency can be heard from far away. Even if a small bell, ding, 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 it has more frequency. If you just ring that bell somewhere in L tower at night, you can hear it from A tower. But if somebody is playing music at L tower, it can be heard maximum in and around there only, not up till A tower. Loud does not mean it travels long. High pitch, high sound. So you know the piano. So we have, say, suppose we have the first octave. So if you play the C note out here, say it's vibrating with a frequency of say 244 hertz. Then the next octave also has a C. This is a middle C, you have another C. That C and this C, this frequency will be just double of this frequency. The next frequency is just double of this frequency. This is the mathematics. So when you learn music at an age, you understand the mathematics part, but your fingers are not that smooth. But at a childhood, when you learn music, you don't know the mathematics, but आपको समझ में आ जाता है. It's very easy. So like many people will tell you, waves and sounds are so interesting. Like they say, what is a scale? Like, you know, say, I know the C scale. You'll see children speaking like that. I know the C scale, but D scale, no, D major में मुझे problem होता है. Nothing like that. Every scale is full step, half step. It goes like that. So you follow the formula from that note. You will again make a scale from there itself. You can design your own scale. Whether you're playing from C major, C minor, B minor, आप अपना whole step, half step, ऐसे करके आप कहीं से भी बजाओ वही होगा. The same frequencies will come, but with double values. Understood? So a frequency, a sound with more frequency can be heard. Now we have to understand this from wave perspective. So let's just, before we conclude today, we'll cover this in next class also, but let's just understand now. इतना जब बात कर लिया, तो एक चीज और बात करते हैं. इन सब चीजों को भी wave में represent करने की कोशिश करते हैं. Let's try to represent everything in terms of wave. So how do we represent them? So we'll try to show it in two manners, okay? Right. So let's say okay. So let's say this is the pendulum that was with me. Do you understand? And this pendulum is oscillating this way and this way. This is this amplitude. तो इसके amplitude को पहले mark कर लेते हैं. ये drawing 3-4 बार draw करेंगे because this is how you understand wave. This is your amplitudes. That means your wave will be between this range. Have you understood? So we show our wave from the mean position. So say from the mean position, the wave is shown in this manner. This is a simple sinusoidal wave. This can be represented in terms of displacement, and this can be also represented in terms of time. Don't get confused. It will take some time for you to understand, but I guarantee you, you will understand. Maybe not today. We can plot the same thing in terms of time also. Okay. As of now, let us plot it only in terms of displacement. So देखते हैं कुछ चीजें whether we have understood or not. Okay. So what did we say? The maximum displacement from the mean position to this. The maximum displacement from the mean position to either extreme. So this will be known as my amplitude. This is also my amplitude. Have you understood? ठीक है. This half semicircle, or the part that you see here, this half portion and this half portion, there are names for this. This one which is above the central position, in wave mechanics we call it crest, and the one which is down we call it trough. One crest plus one trough, okay, equals to one cycle. Crest trough, कुछ भी ले लो आप. Or you can also think on the dashboard of our car, we have got a Mickey and we have got a spring. Mickey goes up, Mickey goes down, Mickey goes up, Mickey goes down. Equilibrium, extension, compression, extension, compression, extension, compression, vibratory motion, to and fro motion. For that also we'll draw this diagram again. I'm just giving this part is just for you to understand. So have you understood what is an amplitude? Amplitude, this is called a positive amplitude, this is the negative amplitude. One crest and one trough gives you actually one cycle. Have you understood this? Okay. If you are seeing this in the diagram where we have plotting it against, say, displacement, that is meters, then from here to here will be called one wavelength. One wavelength. One wavelength is the distance moved by the disturbance over one cycle. Please understand, body move नहीं कर रहा है, wave में हम disturbance को study कर रहे हैं. The disturbance moved from here to here is half wavelength. So crest, wavelength is denoted by the symbol lambda, as I told you in last class. Remember? Now let's draw this figure again on the time scale. इसको time scale में draw करते हैं. तो same figure आएगा ऐसा time scale में. Now this is in time, and let this time be t. Can you tell me what is t? T is time period. Time taken to complete one cycle. Time taken to complete one cycle. This is known as my time period. मजा आया? And if this t was of a value 1 second, say, 1 second में कितना cycle किया? 1 cycle. What is the frequency? 1 hertz. What is the time period? 1 second. If the time period is 1 second, the frequency has to be 1 hertz. Just look at this graph. In how much time did it complete one cycle? Sir, in 1 second. What is its time period? 1 second. In 1 second, how many cycles did it make? What, sir? 1 cycle. So what is the frequency? 1 hertz. समझ में आया? अब मान लो इसको थोड़ा सा चेंज करते हैं, राइट? लेट्स चेंज दिस अ बिट. इसको चेंज करके मैं यहां पे लिखता हूं, this is 2 seconds mark. Now question yourself. Don't see the top one, see the bottom axis. We are plotting this against displacement, this against time. To complete one cycle, it took 2 seconds. What is the time period? 2 seconds. Therefore, in 1 second, how many cycles did it make? 1 second में कितना cycle बनाया? Half cycle बनाया. Frequency कितना हुआ? Half. फिर से देखो आपने क्या डेटा निकाला. आपने बोला t है 2 seconds और आपने बोला frequency is half hertz. तो आपने तो वेरीफाई कर दिया, t is equal to 1/f. इंटरेस्ट से फिजिक्स पढ़िए, रटने वाने से कुछ मजा नहीं है. Then you will solve one problem, not more than that. So we got a fair idea. So next class onwards, we will be moving little bit more deeper into what you call wave mechanics. So next class we have got a maths class and then a chemistry class. So we'll be getting more deeper into wave mechanics in terms of representing the wave schematically, trying to understand what is amplitude, what is frequency, what is wavelength, what is speed of wave. Then we'll also understand something called phase and pulse. लेकिन इससे पहले ये कहानी इसलिए बताया, आपके स्कूल में सारे बच्चे ये वेव पढ़ लेंगे. And then you ask that child, in a sea beach when you are standing, does the water come to you? All of them will say, yes, the water comes to me. वही गलत है. Water doesn't come to you. The same water remains at your place. And if you still don't believe me, ripples, you know ripples, when you go to a pond and you drop one small ripple, जहां पैदा होता है ना वहां पे एक लीफ रख दीजिए, लीफ. Ripples are created like this. Like this, ripples are created. They tend to spread out from the disturbance, right? यहाँ पे हमने पत्थर फेंका. So we'll ask Ashmita to keep a leaf out here. Ripple spread ना, तो लीफ को भी तो जाना चाहिए था. लीफ नहीं जाएगा, लीफ वहीं रहेगा. The water just bubbles up, bubbles down, bubbles up, bubbles down, and that disturbance propagates. तो जो यहाँ पे कभी ऊपर आया था, at that time the next one will be down. And last one example as I talk and I leave you. So this is Diwali right now. There is the balcony of my house right in front of where we are standing, and we have sea tower on the other side. So let's make everything dark, and I put a big band of light where the programming is done such that bulb 1 glows, then 2 glows, then 3 glows, then 4 glows. When 1 glows, everything is switched off. Then 2 glows, everything is switched off. And then we regulate it at a speed. What speed? Speed of persistence, 1 second, 1/16th of a second. 1 glows, 2 glows, 3 glows, 4 glows. And I make you stand on the opposite tower. What do you see? Tick, 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 tick. One light is moving. Is any bulb moving? The disturbance is propagating at a periodic interval. बल्ब 1 जलने के एक निर्धारित समय के बाद ही बल्ब 2 जलता है, उसके बाद ही बल्ब 3 जलता है, उसके बाद बल्ब 4 जलता है. यही चीज आपको जब दूर से दिखाता हूं तो आपको क्या लगता है? हाँ. So when you go to a cash counter or you go next time to PVR or you go to a movie, what do you see at the gate? Now showing. Next theater 6. ऐसा टक 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 आते रहता है ना? That's a dot matrix display. Nothing moves. The bulbs illuminate and glow at a particular time, giving you a feel as if you feel now showing. Avatar, Universal, or Adult, and then Theater 6, Telugu, Hindi, it keeps on. No, that's a dot matrix display. Even I have it at home. It has so many LED bulbs. And the bulbs light in such a frequency that you feel as if everything is moving. You know the time-lapse book which we saw in Tare Zameen Par? So many pictures are drawn and then you do it in this manner. You see the whole thing coming up like a story. Way, illusion. Okay? आज यहाँ रखते हैं. In next class, we will be going across this. So please read a little bit about from your book, what is frequency, what is time period, what is amplitude. Should there be anything that is disturbing you, to let me know. And your voltage cell, we will do. Don't worry. But understand one thing, what you're going to learn now, electrochemical cells. So the entire naming of cathode and anode will change. But do remember the basic definition. Cathode is one at which somebody gains electron. Reduction always happens at cathode. It happened at negative in electrolytic cells. In electrochemical, it will happen at positives. तो लोग समझते हैं अरे एक बार कैथोड पॉजिटिव बोलते हो एक बार नेगेटिव बोलते हो, ऐसा नहीं है. जहां रिडक्शन वही कैथोड. चलिए आज का रंगारंग कार्यक्रम समाप्त हो